Hi, this is Mrs. Vrobel. This is the first part of Matter, Property, and Changes. So in this unit, we're going to be looking at matter. How do we define it? How do we classify it? What are some properties of it? And then what are some changes that matter undergoes? Now here in this first slide, we have a Buddha statue that's from Bangkok, and notice that it's made of gold. So by the end of this unit, you will be able to tell someone what type of matter this statue represents and how it's classified. Now, for students, the easiest type of matter to understand is probably substances. And with substances, we're looking at uniform, constant composition, and that there's only one type of matter. So you might ask yourself, what would be an example of this? Well, the one part that most people recognize within chemistry is elements. So elements have to contain like atoms, but the interesting thing is the elements actually contain molecules, and some people don't realize that. And you might ask yourself, where are those molecules? Well, there's a section within the periodic table, and it starts with nitrogen, and then it goes all the way down to iodine. This upside down L or 7 actually contains diatomics, and this means that nitrogen is a diatomic, iodine is a diatomic. So all these elements within this section are naturally forming diatomics. And this is something that you'll need to know because you may be given a chemical equation and you need to tell me that oxygen is a diatomic. Now, there are approximately 114 elements. However, you may notice that in some of the newer periodic tables, they list elements up to 118. What this means is that there are a handful of elements that have not been accepted as being known elements. Some of the labs that created these elements, they only lasted for femto or picoseconds. So their actual existence on the planet is very fleeting, and the experiments have to be run repeatedly in order to prove that these elements actually do exist. Now, you should have had by now the element symbol quiz, and I'm not going to get into any discussion about that. Now, for types of elements, I kind of scrounged around the house to try to find an example of the first type, and here is a container that you probably have in your backpack or maybe in your drawer at home, and this is a nonmetal. So when you look at this nonmetal, it's a cylinder of graphite. So graphite rods are actually nonmetals. Most of them are gases. One of them is actually a liquid, and you might ask yourself, well, what liquid are we talking about? If you look on certain periodic tables, they will list bromine as a liquid. So some of these nonmetals are solids, some are gases, and one is liquid. Now, if they're solid, typically they are poor conductors, and that's a good thing because you don't necessarily need everything to conduct electricity, and it may be a good insulator, which is essentially what a poor conductor does. Please notice that they also have low melting points, so it doesn't take much for them to actually become liquid. They tend to be simple molecules, so they don't form complex compounds. And please notice that there are essentially 17 of these nonmetals. Now, when you look at the periodic table, I'm drawing it as a rectangle, it's in the upper right-hand corner. So in this section of the periodic table is where you're going to find most of the nonmetals. Okay, now there's another type which we call allotropes, and some of you may have heard of this before, some of you may not. Now, I have an example of an allotrope. You may not have an example of an allotrope, but essentially, my wedding ring is an allotrope of this. So carbon makes up both of these substances. However, there's different bonding going on. So even though both of these contain carbon, this has a different network of carbon atoms than this. And that's why there's a huge difference between the same element. Okay, so for metalloids, I had to scrounge around and find an example of that. And probably the best example is your cell phone. So metalloids make up a chunk of the cell phones because they're used as semiconductors. And the reason why, if you look at some of these qualities of the metalloids, they have properties of nonmetals and metals. So the advantage to the metalloids is you can sort of turn on or turn off the properties that you want for these metals. Notice that they have very high melting points, which is very important, especially if you want to keep them solid for a certain temperature. And there are essentially 7 of these. Now for metals, I scrounged around and I found some examples of it. So a fishing lure is an example of a metal. A penny, well, this was a penny, is another example of a metal. Notice that they're shiny. They can be malleable, which I did here. Some people ask me, what does ductile mean? Ductile means that you can pull it into a wire. So ductile just means that you can take that metal and essentially form a long wire with it. And from your own experience, you probably know that a lot of your pots are heat and electricity conductors. So that's the reason why we have copper pots or we have copper wire for our electricity. Notice that the remaining chunk of the elements are metals. So if you were to look at the size of the periodic table, a good chunk of the elements are essentially metals. Okay. So here is an example of the periodic table. So please remember in this hot corner here, these are all the nonmetals. Here is the upside down L that I was telling you about, okay? So notice that from nitrogen across to fluorine down to iodine, this is all made up of diatomic molecules. And you need to remember that for your chemistry reactions, okay? Notice how a good chunk of this periodic table is metals. Now, the thing that sometimes is hard to remember is hydrogen is actually a nonmetal, even though it's right on top of the metals, okay? So hydrogen itself is considered a nonmetal, even though it's right on top of the metals. And we'll talk about that eventually. And lastly, here is that step stair. And that step stair contains the 7 nonmetals that I talked about with you. I'm sorry, metalloids. Don't tell me why I said metals.